Hi, buongiorno tutti. Thank you for coming to this talk. So let me introduce a little bit of AMI Labs. So we announced our company about 2 months ago. We probably raised the biggest seed round in European history. We are a frontier world model research lab, a company that's headquartered in Paris. And from day one, we have teams in New York, in Montreal, and in Singapore. So we are a global company, but also a European company. And AMI Labs was founded with Yann LeCun and 5 other co-founders. We came from Meta, Google, and the founding team also had members from xAI, OpenAI, and with the ambition of creating world models. And I'm here to tell you what world models are. So for many of us who have been seeing AI evolve in research, so I am foremost a researcher, we have seen people using AI as tools, then as assistants. Those of you who have been using smartphone assistants, you remember that. And AI as agents that are more autonomous than just mere smartphone assistants. And in the future, we can look forward to AI as full partners for humans in our daily lives and daily work. Now, for AI to be full partners, they must understand the world, the real world, like we do. They must understand, they must see, they must hear, they must accompany us and understand not just the online world like AI agents do today, not just help us with workflow on the computer, but also help us in life, in work, in the physical world. You've been hearing about robots at home that help us with domestic chores. You've been hearing about smart glasses that can help you navigate in the real world, that can help you, coach you in your daily activities. If I want to cook a new recipe, I don't know how, and my agent in my glasses should guide me throughout the process. All the while being very proactive, and being very personalized, and so on. So today's large language models, very useful. You are all very familiar with it. You use it for work, for personal purposes, and all the AI agents that are built on top of large language models. Large language models came about from language models, which came about 30 years ago from predicting the next word to help with tasks like speech recognition and machine translation. So I've been in this field for 30 years, so I have seen the evolution of our research. Now, in the past few years, there has been this frenzy of scaling large language models, scaling the foundational models to make our AI agents more and more capable. But today, we know that this is over. We can no longer just rely on scaling the current models. We need a new paradigm. And the new paradigm here, I'm telling you, is what we call world models. So this is a diagram from our co-founder Yann LeCun's talk, position paper from 2022. It shows the human brain and how we function in the world. So what do? We have this cognitive world model where we perceive the physical world and all kinds of laws of physics in this world. And we learn, well, actually, a lot of it we were born with, right? Just like animals, we're born equipped with certain, you can call it pre-trained evolutionary wiring of knowing how to behave in the physical world. A baby knows how to find the mother, and so on. And then as we learn throughout the growing process, we learn from 2 ways. One way is supervised learning. We go to school, we study books, teachers teach us, our parents teach us. We learn from books. Those are supervised learning or system 2 learning. We learn deliberately. We learn from reading. We learn from our teachers. But we also have system 1 learning where we naturally learn from experience, so it's called experiential learning. You learn there's an effect of gravity. Toddlers, very young, they know not to jump, and they know not to go jump off a cliff. Even animals know that. You know, animals, a famous example is that cats can figure out how to turn a door and get out of the room without being taught, right? So this kind of instinct, we call it instinct or reflex in the physical world, is what LLMs are not learning today. LLMs learn from online text and even online captions of images. So they learn from secondhand knowledge of humans. So we write about our experience, and LLM learns about the world through this written documentation. So language is a very good representation of the world, but it is not perfect. So you have LLMs that can learn how to solve a mathematical equation or even a physics equation about gravity, but it cannot relate to the feeling, the experience, the effect, the causal effect of gravity. So this causality in the real world is what the AI models need to learn in order to be our real partners and assistants. So here I'm introducing the model, what we call cognitive world model, which combines the physical world model, which is the understanding of the physical context, as well as mental world model, which is the understanding of human beliefs, intentions, goals, and emotions, social norms, and so on. Combining these two, we can have a unified representation of the real, world, of our reality, so that AI agents of the future will be able to plan, to reason, to help us, and to collaborate with us. So this is a schema of the three-way interaction between the human. So in this case, the human is wearing smart glasses, or human can be talking to a domestic robot. And with the AI agent, again, this agent can be virtual or can be a real robot, and the interacting with the physical world. So humans carry out our daily activities in the physical world or the online world, and the robot or the AI agent help us between the human and the physical world, help us to augment our capabilities, right? So this three-way interaction constitutes this, the future of AI and robotics. And we need cognitive world model to help our AI agents get to that point so that it can help us in the real world. So I'm going to introduce briefly one of the papers we have published from MetaFair previously. So this is a model called VLJEPA. So joint embedding predictive architecture is what we proposed, our founder proposed, as a new architecture for AI models beyond transformer. You probably heard from Leon's this morning about transformers, and it has greatly changed our lives. But JPA is an architecture which enables AI model to perceive and to understand in the embedding space or the semantic space. So instead of trying to learn by predicting the next token or the next pixel, like generative models, this is a non-generative model, which perceives the world, and then it tracks the world, like we do, in the semantic space. And then it plans for the next actions, like we do. What's the next thing I'm going to say? What's the next action I'm going to do? From the semantic space. So this is JEPA architecture, and here this is vision language JEPA, because it perceives input through video, so vision part, and also it takes user intention and user command through language, so it's vision language JEPA. It is non-generative, so it's architecture that does not generate the next token at every instant. It is non-autoregressive, so the prediction is only generates the output action when necessary. So it's not trying to generate a token every single instance. So it's non-autoregressive, non-generative. This is a diagram of a simple diagram of what we do. So you've got it's watching the real world like we do. So it's video input, and in real time, it's encoding that information in the semantic space, so what we call semantic embedding space. And only when necessary, it does selective decoding. So it doesn't output token every instant. It only selectively decodes and gives out the action when necessary. For example, chopping the vegetable, what's the next step, and so on. So what it looks like. So this is a real-time, a VLJEPA tracking human action in real time. On the right-hand side, you see a illustration of the embedding space, the semantic space. So it's looking at what you're doing and decoding whenever the motion changes. It's changing very fast, but it is not decoding the next token. So it's very fast, very efficient. So this is a very efficient model. It's like half of the size of a vision language model. And it's much faster than vision language model. It's tracking your action in real time. So that's the first step to solve real-world intelligence, right? It needs to track what you're doing in real time and listening to what you're saying in real time. I will skip this slide and show you that the benchmark results. It performs better than VLMs. It's half the size, and it's fast. It decodes faster, and it reaches SOTA on all the benchmarks. And so this is also tracking world state, meaning have you accomplished the task? Did you fold? Yes or not? Have you actually successfully picked up the cup? So the robots need to know that, so that's state tracking. Again, this is enabled by VR Jetpack. It's not possible with in real time for VLM today. And another paper we published is showing you, what is this? So it's showing real-time planning of the AI agent. Again, it's tracking your action in real time, but it's also telling you dynamically what is the next step you need to do. It's planning dynamically. It's not generating a static plan. It's following you, planning dynamically. Why does it need to plan dynamically? Because when I'm cooking, it's not always the same. There are infinite ways of cooking. I might move the cup a little bit to the left. I might, in the middle of it, pick up a coffee to take a drink, right? So the planner needs to know what you're doing and needs to reason and plan in semantic space. So again, this vision language world model has reached a SOTA performance, much faster than vision language, than all the biggest vision language models. It works faster, it's more efficient, and so on. This is just the beginning of real intelligence in the real world. So again, to conclude, I want to show you, this is wearing Meta smart glasses. Someone is making a crust. Okay, this is a crust with butter. And as you do the steps, your smart glasses is telling you what's the next step, proactively. So if you're doing the right thing, it won't tell you. But if you miss a step, or if you crack the egg in the wrong place, it will tell you what you should do. Or if you forget the step, it will also remind you what to do. So all this requires real-time and real-world intelligence. So this is the next step of AI agents in the real world. So what does this mean for your business? You need AI that can reason and that can collaborate in the real world. And the Jetpack architecture is designed with safety in mind, meaning that when we can track human intention and actions and social norms in real time, when we can track that, we can also incorporate safety objectives in our training, right? So it's not afterwards post hoc kind of a guardrail. It's not saying if you do this, that's not safe. It is incorporated in our training objective. So this is trust by design, not afterthought. And it will scale your long-term value, meaning that cognitive world model will transform AI into a platform and drive your success through scale, trust, and long-term value in the real world. Thank you very much.